Hello, welcome back to another Sudoku. Today we're going to be looking at Snowflake by Jjesper. Normal Sudoku rules apply. The shaded cells are all either all odd or all even. So let's tackle that first. If these are all odd, then they have to be 7, 9, 5. Two is limited here, kind of. Limited in that box as well. Let's see. There's only 1 4 in the grid. So if this is all odd, that's kind of interesting. No, never mind, that's nothing. If this is all odd, then these have to be 3, 5, and 7. So I was thinking, if those are all odd, then where would 7 go? It would have to be there. A 7 there would restrict this to being 3 or 5, which I think still works. What about 6s? There's more 6s than I would have expected. Do those lead anywhere? There's a couple of 8s left. All these 7s. Alright, maybe it's evens I have to focus on. Yeah, if these are all evens, then they would have to be 2, 8. This would become a 2, 8 pair, and this would have to be a 4. This would become 3, 7 pairs, that would be a 5. There's a lot of implications, but I can't figure out what they mean. What about the 9s? We have a lot of 9s. I don't know if there's enough info yet to figure out the parity, but I don't think normal Sudoku is the way to go. Is there some major problem with this being a 4? If that's a 4, then for the row this would have to be a 6, 8 pair. Actually, there's more stuff going on in terms of, if it's odd, then this square would have to be a 6, 8 pair, and 4 would be slotted down there. I don't know if that's anything either. These are even, it forces a 7 there and there, which seems fine. Oh my gosh, that is it. Okay, if these are even, so that's a 2, that's an 8, and that's a 4, then the 7 in this box is forced to being here. Now using this 7, we can find that this is a 7. And now in this box, this must be a 7. And there's no place to put a 7 here. So this can't be even. It must be odd. Let me see if there's a easier way of solving that. Okay, yeah, so the given 7s would force 7 in here. And then, yeah, there's no way to do that. That's got to be the right way to solve it. But anyways, we got our breakthrough, so now we know this has to be 3. That's a 5-7 pair. And then we got 5, 7, and 9. That can't be a 7. Alright, what else is going on? This has to be a 5 now. 4-8 pair, and the 8 solves that. Okay, what else? Now that we know that those are evens, 4 in here is limited. Oh, 4 in here is limited. That's helpful. Not immediately so, but still. Can we do more 7 stuff? The 7 in here has to be in one of those spots. Oh right, this has to be the 7 here. Which makes this a 7. 7 is in one of these spots. It could be either, because it's odd. Could be there, could be over here. Three, 7, and 9 leave 1 and 5 as possibilities for that square. Six is either there or there. Not sure how helpful that is. No, I just looked at 4s. 3s though. With basic Sudoku, you can see that 3 up there is limited to that spot. Eight with normal Sudoku up here. Oh, right. 8 with normal Sudoku here must go there. And up here. Kind of a confusing endgame here. Let's see, what about 2s? Yeah, we can get another with 2s. Some more pencil marks. These are all slightly off, so I can't do anything with them. Ones, no, I don't think the evens are there. This is missing 1, 7, and 9. So let's just write that in. That can't be a 7. Maybe. Five could be it. I'm not seeing anything though. Got the hiccups. Two, 4, 6, 8. Who do we appreciate? Oh, yeah, it was something obvious. 6 and 4 are both hitting that same area, so that becomes a 6-4 pair. Meaning that this must be odd. This is a 1-5 pair to match. This can't be a 3. Well, that's helpful. That means 3 is in one of those spots. 3 down here is limited now. Eights. Not seeing anything with eights either. This being a 5 has some consequences. Are they useful consequences? Not particularly. Maybe? So in this hypothetical, these all are 5s. Which makes this a 9, and this a 1, and this a 5, and then we have 2 5s. I'm not sure if that's how you're supposed to get that, but pretty cool way of getting that. Okay, what else is going on? It's like my catchphrase at this point. 4, 7, 6. Yeah. 6. 1, 5, 2. Man, I thought that would be the big break that solves the puzzle. Alright, let's just put in all the possibilities. That can't be a 5. These can't be 3s. These can't be 1s. This can't be 7. That can't be 7. This B1 has some effects. Can't quite see what they are though. That's 6 sees this. One, 9, and 5 left to fill in. Nine's up there, kinda. I think these 9s are true because of the red panel, which means this becomes a 9, which affects a few things. It makes that a 9. Imagine having a brain. Makes this a 6. Does 9 do anything else? Means 1, 7, and 5 are all missing here. This is a good one. That 3-6 pair has to mean something, right? It means that this square has to be 1, 7, or 9. This space can't be a 9. Or a 3, actually. What is going on here? Oh, right, this is hard to see. All the odd numbers here are used up, so this has to be even. Can't be 2, 8, or 6. And now that should mean this is a 2-4 pair. Does that help anything else? I don't think so. Okay, gotta check something. Alright. 5, 9, 2, 8, 6 in box 2. We haven't figured out where the 7s go. Where the 1s go. Oh, we have figured out where the 1s go. Well, at least we got one of them. And importantly, this 9 now shoots across, making this a 9. This a 5, and this a 5. This is now a 7-5 pair, which makes this a 1. Now we're getting to the finishing solve here. 5, 7, 1, 2. This is missing a 2. I have no idea about where that could go, I guess. That is irritating. What about this area? It's missing a 4 and 2, I guess. Can't figure that out. But it does help out. If you look over here, you see a similar cell, which means there can't be a 2 or 4 anywhere else in the room. 8 is placed. 6. We could look at 6s now. That's not good. 6 could be either here or here. What about 1? You gotta be getting closer to solving that mystery. can't be a 4. One is now limited. Yes, 1 is limited to the same spots, which makes this a 1. As well. Not in quite the same way, though. Where does 4 go? It can't go here. It can't go there, so it must be here. Which I think solves it. Wow, what a puzzle. This was really something. We got an X-wing on those. Can't get too ahead of myself here, though. This can't be a 6, so that becomes a 6. This X-wing there. This can't be a 1. Right, this 6 makes that a 3, which which is nice because it gives us that. That inherits the properties of that cell, which is a 5 or a 9. Why do I have this penciled in as a 7? Has it been like that the whole game? These have to be all even numbers. Six, 8, and what else? 1, 2, 3, 4, 5, 6, 7, 8, 9. There has to be a 9 in one of these spots. Ah, this 9 is looking at this. This is why I love this notation. Look at how fast I'm flying through this. So not too much commentary on this one, but hopefully you liked it anyways. I don't know why I put a 4 in there, but anyways, if you enjoyed this classic, feel free to leave a like, and tell me which puzzle to try out next. This was a lot of fun, Jjesper. Thanks for sharing.